All right, ladies and gentlemen, let's look at solving a quadratic equation in standard form using the quadratic formula. So we know a is the coefficient of our quadratic term, ax squared. B is the coefficient of our linear term, bx. And then c is our constant that stands alone. Remember, we can always hear my lovely voice singing the quadratic formula to the tune of Pop Goes the Weasel, or you can YouTube that on your own. But you need to know your quadratic formula and be able to pick out your pieces A, B, and C so that you can solve for x, which means we're finding our solutions, our x-intercepts, our roots, our zeros, without having to do graphing or completing the square or factoring. We can find our x-intercepts using our quadratic formula because it is just a generalized version of completing the square and solving. So let's go ahead and get started with our first example that we are working on the back of your notes page. 3x squared minus x plus 1 equals 0. First thing to check is to make sure that it's equal to 0 so that we're truly seeing our pieces. And then we want to take special attention to whether or not we are written in standard form, like in descending order. Our x squared, our quadratic term, then our linear term, and then our constant. I was doing a little study guide with my daughter tonight, and it was written in reverse. And so she had her letters backwards, so be careful of that. All right, so my A is 3, my B is -1, and my C is 1. And so we'll go to our quadratic formula. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. And so remember, we are opening up those empty parentheses so that we can drop in our values in the appropriate spot. So x equals -b. We said our b is -1, plus or minus the square root of b, which is -1, squared, minus 4 times a, which is 3, times c, which is 1, all divided by 2a, and a is 3. All right, and then it's just a matter of simplifying. X is equal to negative times the -1 would be +1. Remember, we're doing the opposite of b up front. Plus or minus the square root. -1 squared. -1 times -1 is +1. And then 4 times 3 is 12. Times 1 is still 12. And then last step, we'll subtract. Following our order of operations, exponents, then multiplication, and then subtraction. All divided by 2 times 3 is 6. So x equals 1 plus or minus the square root of -11 divided by 6. Can we simplify? Yes. Yes, we can, because we know the square root of a negative is not a real solution. That sends us to the land of imaginary. And so we're going to need to use our definition. The square root of -1 is equal to I for imaginary. So go ahead and extract that -1. And so we would have x equals 1 plus or minus I square root of 11. So since we have extracted that negative, notice now our radicand is a +11 inside of that radical, all over 6. And we're checking. We have a 1, a 1i, and a 6. The only common factor between those three numbers is a 1, so we cannot reduce or simplify further. Okay, let's try another. Example 2, 3x squared plus 2x plus 3 equals 0. It does equal 0. We are in descending order, x squared, then x, then our constant. So my a is 3, my b is 2, and my c is 3. Take time to go ahead and write out your formula with those open parentheses. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Oops. Open parentheses. We don't need that a there, do we? All right, so negative b, my b is 2, plus or minus the square root of b, which is 2, squared, minus 4 times a, which is 3, and times c, which is also 3, all divided by 2a, and my a is 3. Okay, so let's follow our order of operations, start simplifying what we can here. So x equals negative 2 plus or minus the square root of 2 squared is 4. Exponents first. Then we'll hop over and do our multiplying. 4 times 3 is 12. And 12 times 3 is 36. And then we'll come back and we'll subtract those two. All divided by 2 times 3 is 6. So x equals negative 2 plus or minus the square root of negative 32, all divided by 6. And then we need to work on simplifying that radical. Remember, I have a separate video loaded if you need a workshop on simplifying radicals. But we first see that negative means no real solution, so we have an imaginary solution. So we'll extract that negative from our square root. So first, we would have x equals negative 2 plus or minus I, square root of 32, all divided by 6. And so then let's go off to the side and let's work on our square root of 32. Square root of 32 is the same as the square root of 16 times 2. And we know the square root of 16 is 4, so 4 square root of 2. So what we would do is we would take that square root of 32 and we'll break that down into the 4 square root of 2. And technically this is the order that it should look like, 4i square root of 2. Okay, and again, if we are going to simplify, we can't touch that square root of 2. That 2 is trapped. So we're just going to look at our negative 2, our 4, and our 6. If there's a common factor between those three numbers, then we will go ahead and reduce to simplify further. So all three of those have a common factor of 2. So negative 2 divided by 2 is negative 1. Plus or minus 4 divided by 2 would be 2i square root of 2. All divided by 6 divided by 2 is 3. So that would be our final solution. Okay, last one. 4x squared minus 2x plus 8 equals 7. Again, we're in descending order, x squared, x, and our constant. But notice how we're not equal to 0. We're actually equal to 7. So let's go ahead and subtract so that we can be in standard form. 4x squared minus 2x plus 1 equals 0. And now we can identify a is 4, b is negative 2, and c is 1. Okay, using our quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And then let's go and substitute our values. We know our b is negative 2. Again, b is negative 2. A is 4. C is 1. And our a is 4. Okay, and then let's clean that up. X equals negative times a negative makes positive 2. Plus or minus the square root of negative 2 squared. Negative times negative is a positive 4. and then multiply. 4 times 4 is 16. 16 times 1 is still 16. That's what we'll be subtracting. All divided by 2 times 4 is 8. Okay, so x is equal to 2 plus or minus the square root of negative 12 divided by 8. So we see two pieces. We see square root of a negative that we can simplify because square root of negative 1 is equal to I. We also see that we have the square root of 12, and we want to see if we can simplify that. Is there a perfect square that we can extract from the square root of 12? That's the same as the square root of 4 times 3, and the square root of 4 is 2. So we could simplify the square root of 12 as 2 root 3. All right, so we would have x equals 2 plus or minus 2i square root of 3, all divided by 8. And again, we're going to leave our 3 as the radicand. Can't touch that. We're just going to look at our outside numbers, 2, 2, and 8. Is there a common factor? Yes, yes, there is. They are all even. So we have a common factor of 2. 2 divided by 2 would be 1. Plus or minus 1i square root of 3, all divided by 8 divided by 2 is 4. So that would be our final simplified solutions. Remember, you have two solutions, 1 plus I square root of 3 divided by 4 and 1 minus I square root of 3 divided by 4. Both of them are imaginary, which means that if we were looking at the parabola for this quadratic function, analyzing that graph, we know that we would have a parabola that never intersects the x-axis. So we don't have any real solutions. We have two imaginary solutions. All right, so why don't you try that and see if you have any mistakes, any questions. If you need to go back and work on simplifying radicals, stay tuned for that video.